In the previous class, we had discussion over the gas laws. The first law is known as Boyle's law. The Boyle give the relation between pressure and volume by kept temperature and given a mass of a substance constant. These are the measurable properties: temperature, pressure, volume, and amount of a substance. So these are the measurable property. By considering the measurable properties of the gases, the different laws were explained. The first thing is Boyle's law. The Boyle's law states that at a constant temperature, volume of a given mass of a gas is inversely proportional to pressure, or pressure is inversely proportional to volume, vice versa. Let's move on to the second law. The second law is nothing but Talus law. Charles and Gay-Lussac. So these two scientists worked on gases by considering different measurable properties. During his several experiments, they found one thing, that is the relationship between temperature and the volume. The relation between temperature and volume of gases is given by Charles and Kelvin. This relation is obtained during his experiment by considering hot air balloon. So, what are the things involved in his experiment? First, he considered a balloon filled with the hot air. Okay, it is filled with the hot air. During his experiment, they filled fixed amount of a gas. Fixed amount of a gas is mass or amount of a substance is fixed. That means N is mole of a substance or gas is constant. And the next case is volume kept constant. Volume is constant. Pressure is constant. In the first case, pressure kept a constant. Okay. Pressure kept, how to kept pressure kept a constant? So consider one constant system. Here there is no change in the pressure. Okay. Suppose you consider in your classroom or in your home or anywhere. Okay, the pressure always remains same. So constant. Amount of a substance is constant. Okay, ಇದು ಒತ್ತಡ ಇಲ್ಲ, amount of a gas ಏನಿದೆ ಅದು ಫಿಕ್ಸ್ ಇದೆ. Next, they filled a hot air. Okay, first hot air ಅನ್ನು ಒಳಗಡೆ fill ಮಾಡಿದ್ರೆ balloon ಒಳಗಡೆ. What happened and what are the things observed? Suppose temperature of the system. Suppose the temperature of the system is increases to T to T1 degree. Suppose temperature is increases from 0 degree to 1 degree, like that. Okay, initial temperature is T, capital T, and the next temperature is T1. During that time, or when increasing the 1 degree of the temperature of the system, the volume of the balloon also increases. What happened? Volume of the balloon is increases. How much quantity? The volume of the balloon is increased by 1 by 273.15 amount. This much of volume is increases. When we compare to the initial volume, the volume of the balloon is increases by 1 by 273.15 of its initial. So next, they continue the experiment by changing the temperature. Temperature is decreases from T1 T to T2. Okay, So initial temperature is T, and next is decreases. Temperature decreases, here increases. When temperature decreases, volume of the balloon also decreases. How much quantity of volume decreases during their experiment? The amount of volume decreases is equal to the again this much for every or per degree temperature. That means 1 degree temperature, when 1 degree temperature is rises, then 1 by 273.15 amount of volume increases. When temperature is decreases from or decreases 1 degree or fall in the temperature, then 1 degree, then also 1 by 273.15 amount of volume decreases. What it indicates, what is the conclusion? ಏನಾಗ್ತದೆ ಇಲ್ಲಿ 1 ಡಿಗ್ರಿ ಟೆಂಪರೇಚರ್ ಹೆಚ್ಚು ಮಾಡಿದರೆ ಇಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ವಾಲ್ಯೂಮ್ ಹೆಚ್ಚಾಗ್ತದೆ, ಇಷ್ಟು 1 ಡಿಗ್ರಿಯನ್ನು ಕಡಿಮೆ ಮಾಡಿದರೆ ಅಷ್ಟೇ ಅಮೌಂಟ್ ಆಫ್ ವಾಲ್ಯೂಮ್ ಸಣ್ಣ ಆಗ್ತದೆ, ಗಾತ್ರ ಸಣ್ಣ ಆಗ್ತದೆ. ಸೊ what is the conclusion? It conclude or it give the conclusion that every 1 degree rise in the temperature, the volume of the system is increases this much, and every 1 degree fall in the temperature, volume of the system or balloon decreases this much. So that is the conclusion of the experiment. By considering the experiment, this experiment, Charles and Gay-Lussac give the statement. That statement is known as Talus Law and Gay-Lussac Law. There are two laws. One law gives the relation between temperature and the volume. Okay, this is about volume. And another one gives the relation between temperature and the pressure. Here pressure is kept constant. In case of Gay-Lussac law, that pressure varies and volume kept constant. So that is the differences. Okay, let us discuss about the Talus law in detail. What is the statement? According to this experiment, the Talus law gives the statement at what are the things constant here? Constant things is amount of substance and pressure. At constant pressure, okay, constant pressure, the volume of the gas, it is not exact statement, according to the experiment, volume of the fixed mass of a gas increases or decreases by 1 by 273.15 of its initial volume when 1 degree rise or falls in the temperature. Okay, here what it says, at a constant pressure, volume of a fixed mass of a gas increases or decreases by of its initial volume when 1 degree rise or falls in the temperature. So 1 degree rise ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ, sorry, okay, 1 degree, every 1 degree increase in the temperature, volume is increased by this much, and every 1 degree fall in the temperature, volume is decreases by this much. So 1 by 273.15. By considering this statement, okay, this is the first statement about the law. By considering the statement, the mathematical form is become, okay, suppose consider, okay, if consideration it is, if initial volume. Okay, initial volume is V naught, and the temperature, it is for the temperature, initial volume for the temperature T naught. Okay, T naught. In the initial condition for T naught temperature, the volume is V naught. Now, next, what happened? What is the change in the volume? What is the change in the volume as per the law? Okay, what is the change in the volume when temperature is increases from T naught to T or T naught to T1, like that? Okay, V is increases when temperature is increases, volume also increases. No, according to the statement, the next volume. Okay, now temperature ಹೆಚ್ಚು ಮಾಡಿದಾಗ ಎಷ್ಟು ವಾಲ್ಯೂಮ್ ಆಗ್ತದೆ ಅದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ V is equal to initial volume. What we do in this case, we are increasing the temperature. So we are increasing the temperature, therefore plus. Suppose we decrease the temperature, now it becomes minus. It is the initial volume. Compared to the initial volume, final volume is increases. How much? Final volume is increases compared to the initial volume by 1 by 273.15 amount of initial volume when temperature is rises to T degree, T naught to T degree. Okay, so when temperature is rises to this much T degree, then the volume is increases by this much of its initial volume. Of its initial volume means we should consider V naught again. Now V is equal to, when we simplify this equation, we got a equation V naught is a common factor. Now it become, okay, what is the simplified equation? Can anybody guess? 1 plus, here V naught goes to common and T comes to this place, T divided by 273.15. Again I am, suppose it is equation number 1. Okay, again I am simplify the equation. 273.15, it comes to this side, plus I am taking 273.15 as a common, T, okay, for LCM like that, 273.15. Here equation number 2. In equation number 2, the quantity of this temperature, quantity of this much, this is a one temperature. No, it's a temperature increased amount, and this is the 273.15 amount of volume increases 1 by of its. Therefore it becomes the one temperature now, different temperature now. This 273.15 plus T degree Celsius. So this one is known as Kelvin scale temperature. Kelvin scale temperature, very important. Okay, this is known as Kelvin scale temperature or thermodynamical scale temperature. Okay, Kelvin scale or thermodynamical scale temperature. How much? 273.15 plus T degree. It is considered as, now it is considered as TC. Why it is TC or TK? Better to consider as a TK, Kelvin scale temperature. Okay, substitute that Kelvin scale temperature here. V is equal to V naught. Substitute in equation 2. We got our equation 273.15 is equal to Tk divided by 273.15. It is the initial. Now it becomes the initial temperature. So I am consider it as a T naught. Now it is a T naught. Okay, 0 degree. Okay. Again I am simplify the equation. V divided by V naught equal to Tk divided by or when we consider the final things one side and initial things one side. Okay, now it become V by Tk equal to V naught divided by T naught. What it gives, suppose it's a final. Now just rearrange or the consider the different concept here. It is a final, correct? This is the final volume, this is a final volume, and this is the final temperature, and these two are the initial volume and initial temperature respectively. Therefore I am consider initial, suppose the initial system is 1 and the final system is 2, equation 3 become, if we consider like that, equation 3 become, or we can easily change into another form into V2 divided by T2. Why? It is a final temperature T2, this is a final volume V2, and this one is V1 by T1. Both are equal. What it says, both are equal means the ratio of the first ratio of volume and temperature of the first system is equal to the ratio of the volume and temperature of the second system is same, means V by T is equal to constant. Then only this equation become true. Correct? Equation number 4, equation number 5. Now equation number 5 become the definition of the Talus law. What it says? V by T is constant. What is the meaning of V by T is constant? Or when we remove the constant, or when we add the proportionality constant, the equation become, by considering the proportionality constant for equation number 5, equation number 5 becomes V is equal to K2. Why I am considered K2? K is a proportionality constant. It is for second law. Therefore, it is K2. V is equal to K2 into T. When we remove the proportionality constant, V is directly proportional to T. What it does? V is directly proportional to T. V is directly proportional to T. What is the meaning of V is directly proportional to T? V is varies directly with the temperature. What is V? Volume. What is T? Temperature. What are the things kept constant? Here pressure kept constant. Correct? According to the statement it is. According to the statement, pressure kept constant, amount of a gas is constant. How volume varies with temperature? Volume is directly varies with temperature. Now what is the statement of Talus law? Talus law states that at a constant temperature, constant pressure, at constant pressure, volume of a given mass of a gas, volume of a given mass of, or fixed mass of a gas varies directly with temperature. So this is the statement of Talus law. In another word, at constant pressure, volume of a given fixed mass of a gas directly proportional to temperature. Okay. So now it become very easy. The statement or definition become now easy. Correct? So according to the experiment, there is a one statement. It is also true. Okay, it's also correct. Suppose in your exam, define Talus law, they given that define Talus law, you can write anyone. Okay, so ಇದನ್ನು ಬರಿಬಹುದು, ಅದನ್ನು ಬರಿಬಹುದು, both is correct. Okay, so ಇದು ಯಾವುದರ ಮೇಲಿಂದ, after simplification of the mathematical form of the experimental statement. So that experimental statement give the, or obtained from their experiment. Okay, it is a mathematical, it is obtained from mathematical form. Okay, so this is the Talus law. What is the mathematical form now? According to the statement, V is directly proportional to T. V is equal to K to T, or V by T is equal to constant. So this is the mathematical form of Talus law. Suppose in your exam, the question is asked about the Talus law, you should write this much, it is enough. Okay, this is for knowledge purpose and what they did in here, their experiment. Okay, so these are the things, mathematical equations. Okay, so this is about the Charles law. Now, as similar as that of the Boyle's law, what is the graphical representation of Charles law? The graphical representation of Charles law is, how to put the graph for this one? It is a graph for volume versus temperature, correct? You can consider anywhere. Okay, I am consider volume along y-axis, temperature along is a VT graph. Okay, V versus T, temperature along x-axis. How volume varies with temperature? It is directly varies with the temperature. Therefore, as temperature increases, volume increases. How? Directly. So gradual increases. Gradual increases of volume as increasing the temperature. Question arises now. I am not considered it is from the origin. What is the reason of I am not considered it is the origin? Volume never becomes zero. No. In our system or in your universe, volume never becomes zero. If the volume of the system is zero, then nothing is there. So there is no meaning. That's why I am considered at the 0 degree Celsius also, at the 0 degree Celsius also, system has some volume. So this one is V naught, has initial volume, some volume at 0 degree Celsius. That volume is considered as a V naught. So if we are considered water at 0 degree Celsius, it has some volume, nice. All thing has some volume at 0 degree Celsius also. Now question is arises. When volume becomes zero, it is possible? It is possible in graphical representation. When it becomes zero, it is for T1 temperature. Okay, just imagine it's for a temperature to 300 Kelvin, T1. Okay, when we consider the minus x-axis in the graphical representation, suppose we consider or now temperature volume ಅನ್ನು ನಾವು ಬ್ಯಾಕ್ವರ್ಡ್ ತಗೊಂಡ್ರೆ ಏನಾಗ್ತದೆ? So it crosses the temperature curve here. What's the meaning? It is temperature 0. Now volume also becomes 0. No, temperature is not 0. No, temperature gives some negative value, negative temperature. Volume is 0. When this case happens, or when temperature curve crosses the this temperature, sorry, it is for pressure 1. For the pressure 1, temperature varies like that. Pressure curve crosses the temperature curves here. This temperature is, when you measure the temperature here, it is minus 273.15, minus 273.15. It's theoretical things. Okay, it's a theoretical things. It is hypothetical one. Hypothetical means just imagination point. There is no existence, or there is no proof about the existence of this such cases. It is now lot of research are taking place on this field. Okay, you can obtain a lot of knowledge by from your YouTube videos or anywhere of in your internet sources. Okay, this one, about this one. Okay, next another curve, all the pressure curve crosses the temperature curve at minus 273.15. This temperature is called as absolute zero. This one is known as absolute zero. What is the meaning of absolute zero now? Absolute zero is nothing but it is a hypothetical temperature. Yes, it is a hypothetical temperature at which, what happened at that case, at which volume of the system becomes zero. That is absolute zero. Volume is zero. Okay, temperature at which volume is zero, volume of the system becomes zero. It is known as absolute zero. Next, what is the name of these curves? There are a lot of curves, correct? P1, P2, P3 like that. Pressure curve, constant pressure curves are called constant, therefore iso. In case of Boyle's law, temperature is constant, temperature curve, constant temperature is called isotherms. Here this is a pressure, isobars. These are called isobars. Bar is the SI unit of or the unit of pressure. So it's a measurement. Bar is one type of measurement, therefore we call it as using the bars. We explain the curves. Constant temperature curve is called isobars. Okay, so this is about the Talus law. What are the things we discussed here? Talus law. What is the Talus law? What are the experiment? Hot air balloon experiment. From their experiment, Charles and Gay-Lussac concludes how volume is varies with the temperature and all that, and when we simplify the equation, we got V is directly proportional to T at constant pressure, and when we put a graph for volume versus temperature, we obtain curves. These curves are called constant pressure curves, are called isobars, and the isobars always crosses the temperature curve at minus 273.15. That temperature is known as absolute zero, because volume becomes zero at that temperature. You can put the temperature 0 for or minus 273 in the mathematical form of Charles law, then also we got the same thing. Okay, just I give the proof. V is equal to V naught plus when increase the temperature, correct? When decreases it is minus 1 by 273.15 into T. When T is 0, what happened? T is 0, whole thing becomes 0, V is equal to V naught. T is equal to 0, V is equal to V naught. Has some volume, initial volume at 0 degrees Celsius also. Suppose it is minus 273, then only whole thing get cancelled, 0, V is become 0, correct? So this is about the proof of the graphical representation from the experimental equation. Okay, so this is about the Charles law. In the next video we will discuss about the Gay-Lussac law and the another one